Trying to understand dietary advice in the modern day can feel like navigating a maze. For example, on a given day, a source can tell you that nuts are a superfood. On another day, a different source may tell you that nuts are dangerous and should be avoided. You can find contrary headlines for basically any food out there, but obviously both positions can be right at the same time. So why does this happen? It happens because the vast majority of nutritional studies have major flaws and hence cannot be trusted. In this video, I'm going to break down 4 reasons why most nutrition science is junk, and I'm also going to give you tips to understand which scientific studies you can actually trust. Let's get into it. The first reason why most nutritional science cannot be trusted is because most of it is based on something that's called epidemiology. Epidemiology is basically just making decisions and doing science based off correlations, something that you see a relationship between two different objects or behaviors. A simple example to understand epidemiology and correlations in nutritional studies could be comparing fruit consumption with heart disease rates. Anything I'm going to say right here is not an actual study, it's just me giving an example to get the point across. So let's say you do a study where you look at two groups of people, one who eats a lot of fruits and another who eats very little fruits, right? And you're comparing that against heart disease. You might find in an epidemiological study that the group that eats less fruit has a higher rate of heart disease, whereas on the contrary, a group that eats a higher amount of fruits has a lower rate of heart disease. This is what we call an inverse correlation. Much of nutritional science is actually done based on this kind of methodology, but these methodologies have a huge flaw mainly in the fact that you've probably heard this being said many times, but correlation can never inform on causation. The reason that correlations cannot inform on causation is because they cannot control for confounding variables. A confounding variable is basically any third or fourth or whatever fifth action that could be going on in the background that we're not accounting for, but could be causing this difference. So in our fruit example, it could be that the group of people who eat more fruits and have lower heart disease, maybe they also exercise more. On the contrary, I can give another example of a correlation which will show this very well. So there is a correlation between ice cream consumed on a hot day and heat strokes. So would it be intuitive or smart to conclude that eating a lot of ice cream is what causes heat stroke? No, obviously not. We all know that there's some kind of third factor, there's some kind of confounding variable there that's causing the heat stroke, which is that it's a sunny day, it's a hot day. People tend to eat more ice cream on a hot day, and as a result, they also tend to have more heat stroke on hot days. Saying that ice cream is what's causing the heat strokes would be, frankly, stupid. And that's what a lot of nutritional science does.